Hello friends. Now in this video I will explain question number 1 from miscellaneous exercise. Okay. Now let's remember some important formulas. Truth table for conjunction. Now here P is double T double F, Q is TF TF. When P and Q both are true, then it is true, otherwise false. You can remember like this. जेव्हा P आणि Q या दोघांच्या व्हॅल्यू TT असतील तर T, otherwise false. Means what here? TF is F, FT is again F, FF is F. When both of them are true, then it is true, otherwise false. For disjunction, again here P and Q. Okay, when both of them are F, then it is F, otherwise true. Okay, here T is T, TF is again T, FT is a T. And when both of them are false, then it is a false. You can remember like this. ज्यावेळेस दोन्ही FF असतील तरच F, otherwise true. Okay. Now next, truth table for conditional statement. In conditional statement, if both of them are same, then it is true. For example, here TT, both of them are same, then it is true. Here FF, both of them are same, then it is a true. Otherwise, what implies? Means what? T implies F and hence it is a F. F implies T, therefore it is T. या प्रकारे तुम्ही लक्षात ठेवू शकताय. जेव्हा या दोघांच्या ट्रूथ व्हॅल्यू सेम असतील, it means that TT is again T, FF is again T. Otherwise, what implies? Means what? T implies F and hence here is a F. F implies T and hence here is a T. You can remember the conditional table like this. Now next, truth table for biconditional. In biconditional, when both of them are again same, then it is a true. Here TT, therefore it is a true. FF, it is again true. Okay, and if they are not same, then it is false. Here T and F, they are different, therefore it is F. FT, they are different, hence it is again F. You can remember like this. Again I will repeat here. For the biconditional statement, if the truth values of both P and Q are same, then it is a true. Means what here? T is T, FF is again T. Okay, both of them are same, therefore it is true. And if they are not same, then it is F. Here T, F, they are not same and hence it is F. F, T, they are not same and hence it is F. Okay, next, tautology. A statement pattern whose truth values is true for all possible combinations of truth values of its prime components is called a tautology. We denote tautology by T. Statement pattern P or negation of P is a tautology. Contradiction. A statement pattern whose truth value is a false for all possible combinations of truth values of its prime components is called a contradiction. We denote contradiction by C. Next, a statement pattern P and negation of P is a contradiction. Okay. And the next, contingency. A statement pattern which is neither a tautology nor a contradiction is called contingency. P and Q is a contingency. Okay. Now next, important table for all connectives. Now you can remember like this. That is here P, that is a double T double F, Q is a TF TF. Negation of P. Okay. Negation of P is a T is replaced by F and F is replaced by T. That is a negation of T is a F. Again T is a F and F is T, F is T. Okay. Next P and Q, P or Q, P implies Q and P double implication Q. Okay. Now next, in a statement pattern, different symbols are considered in the following priority. Now first is negation, next or, next and, next implication, and the last is biconditional. Okay. Now next, this is important, negations of compound statement. Now see this here, negation of P and Q is equivalent to negation of P or negation Q. Next, negation of P or Q is equivalent to negation of P and negation Q. Now, P implies Q is equivalent to negation of P or Q, and therefore they are negations. That is, the negation of P implies Q is equivalent to P and negation Q. Now next, P double implication Q is equivalent to P implies Q and Q implies P. And the negation of biconditional, see this here. The negation of biconditional means what? P double implication Q is equivalent to P and negation Q or Q and negation P. All these are important negations of compound statement. Okay. Now next, converse, inverse and contrapositive. From implication P implies Q, we can obtain three implications called converse, inverse and contrapositive. Now first, that is the Q implies P is called the converse of P implies Q. Next, negation of P implies negation of Q is called the inverse of P implies Q. Okay. And the last, that is a negation of Q implies negation of P is called the contrapositive of P implies Q. Okay. Now the next, algebra of statement. All these are also important statement. Okay. Now next, miscellaneous exercise 1. I will explain question number 1 only in this video. Select and write the correct answer from the given alternatives in each of the following questions. First, if P and Q is false and P or Q is true, then dash dash is not true. Okay. Now here P and Q is false and P or Q is true means P and Q, both of them have different values. Okay. And here it is already given that P or Q is true. Therefore, this is not possible. P double implication Q, and this is the correct one because both of them must have the different truth values. P and Q must have different truth values, and in double implication, if this statement P and Q have, if the both of them have different values, then its a truth value is false, and hence B is not true. And here is also answer. It's a clear that both have means what? P and Q have different truth values. Okay, then their double implication is a false. Okay, option B is a correct here. Now next question. P and Q implies R is logically equivalent to P implies in bracket Q implies R. B option, P and Q implies negation of R. C in bracket negation of P or negation Q implies negation of R. D, P or Q implies R. Okay. Now we'll see here. That is the P and Q implies R means it is equivalent to negation of P and Q or R. Okay. And if you apply the negation for this bracket, then we'll have here negation of P or negation Q or R. Okay. And hence here by associative law, we will have here negation of P or in bracket negation of Q or R. Okay. And hence negation of P or in bracket negation of Q or R is equivalent to P implies in bracket negation of Q or R, and hence again negation of Q or R means what? Q implies R, and hence that is a P and Q implies R is equivalent to P implies in bracket Q implies R. Okay, and hence option A is a correct here. Now next, inverse of statement pattern, that is in bracket P or Q implies in bracket P and Q is. Okay. Now first option A is a P and Q implies P or Q. B, that the negation in bracket P or Q, negation of in bracket P or Q implies P and Q. C, in bracket negation of P and negation of Q implies in bracket negation of P or negation Q. And D, in bracket negation of P or negation Q implies in bracket negation of P and negation Q. Okay. Now the inverse of statement pattern in bracket P or Q implies in bracket P and Q is, see this answer, that is the inverse of P or Q implies P and Q is equivalent to negation to this statement, that is the negation of in bracket P or Q implies negation of P and Q, and if we apply the negation for this bracket, and then it will become negation of P, this or will become and negation Q. Again implication, if we apply negation to this bracket, then it will become negation of P, this and will become or negation Q, and hence here the option C is a correct here. Now next, if P and Q is F, P implies Q is F, then the truth values of P and Q are. It's clear that the truth value of P is true and the truth value of Q is F. Now see this here. Here the option, that is the P implies Q is F if P is T and Q is F, and hence option B is correct here. Now next, the negation of inverse of negation of P and Q is, first option A is Q and P, B is negation of P and negation Q, C is P or Q, D is negation Q implies negation of P. Okay, now we'll find out the negation of inverse of negation of P implies Q. First we'll find out inverse of negation of P implies Q, then its negation. Now see this here. Negation of inverse of negation of P implies Q. That is, first we find out here inverse of negation of P implies Q. Its inverse is nothing but negation of P implies negation of Q. Now again here negation of negation P is a P implies negation Q is as it is. Now what about the P implies negation Q? P implies Q, P implies negation Q is equivalent to negation of P or negation Q by the formula. Again, we will apply the negation to this statement, means what, negation of in bracket negation of P or negation Q. Now again, if we apply the negation for this negation P, then it will become P and this or will become and again negation of negation Q, that will become Q, and hence finally we have P and Q. Okay, now again I will repeat here the inverse of, first we apply the inverse to this statement by applying the negation sign to these both the statement, that is the negation of P and Q. Here we are applying the negation sign. After applying the negation sign, we get P implies negation Q and P implies negation Q. This is equivalent to negation of P or negation Q. Next, apply the negation for this bracket and then you will get here P and Q, and hence option A is correct here. Now next, the negation of P and in bracket Q implies R is, the first option A is negation of P and in bracket negation of Q implies negation of R. B is P or in bracket negation of Q or R. C option, negation of P and in bracket negation of Q implies negation of R. And D option, negation of P or in bracket Q and negation R. Now we'll apply the negation for this statement. See this here. The negation of P and Q implies R is, it's equivalent to, that is the negation of in bracket P and, okay, now what is the Q implies R? Q implies R is equivalent to negation of Q or R. Okay, now next, apply this negation to this whole bracket. This P will become negation of P, this and will become or, and the negation to this whole bracket. That is a negation of, in bracket, negation of Q or R. And hence, you will have here negation of P, or if you apply negation to this bracket, then you will get here negation of negation Q, you will get here Q, and this or will become and this R will become negation R. Okay, and in this way option D is a correct here. Now next, if A is equals to, in curly bracket, 1 2 3 4 5, then which of the following is not true? First, there exists x is in A such that x plus 3 is equals to 8. Yes, this is correct. There exists, that is, we have here 5 plus 3 is equals to 8. There exists 5 such that 5 plus 3 is equals to 8. This is a true. Next, there exists x is in A such that x plus 2 is less than 9. Okay. Yes, it's also again correct. If we take 2, that is a 2 plus 2, 4. 4 is less than 9. This statement is true. Next, for every x belongs to capital A, belongs to set A, such that x plus 6 is greater than or equal to 9. For every x, it is not possible. If we take x is equals to 1, then 1 plus 6 means what? 7 is a greater than or equal to 9. Hence, this is not true. And hence, option C is a correct here. Okay. And in this way, we have completed the first question. Now we'll see in the next video. Till then, goodbye.